All right, we're going to do this just for fun. Usually breadth first search is implemented the way we saw it, just using a iterative approach. But for fun, I want to see if we can do a recursive breadth first search. And in order for us to do a recursive breadth first search, we can create a new function. We'll have R here for recursive. And in here, we need to create a base case, when to stop. And we will stop if q dot length is 0. Or we can just say when q dot length is 0, like this. If that's the case, we want to have our base case and return the list. But you'll notice here that I haven't defined what queue and list is, like I did with our iterative approach. And that's because if I go to the top here and declare these variables like I did, because in a recursive function, this function will be called over and over, we're going to be resetting these variables and lists over and over to an empty array. So the way we would do this in a recursive function is that we need to actually pass queue and list as a parameter. So that when we call it down here, instead of doing it this way, we'd have to say that the queue will have the this.root node. But remember, the queue has to be an array, so we just wrap this in curly brackets. And in JavaScript, this shows that we have an array with item of this.root, kind of like we did with breadth first search the first time around, right? The initial queue had the current node, which was this.root, our root node. And then the second parameter would be the list, our answer, which will start off with an empty array. So now that we have these, and that's a bit of a gotcha when it comes to recursive functions, we can now do something similar to what we did the first time around with our iterative approach. We'll say that our current node, let's use let here, let current node equal to this dot q dot shift. Again, same thing as we did up above over here, to grab the current node. And then we can actually just copy what we did over here. If current node left, q push the left node. If current node has a right child, then push it to the queue as well. So I'm just going to copy this and add it over here. Make sure the indentation is working. That's better. And finally, because this is a recursive function, we want to return the function so that it goes through again, and this time giving it the queue and the list. And I know this can get a little bit confusing. You might have to look at it, but going through it step by step in your head, you might want to grab this code after this video to see how it works. It's not that much different from the iterative approach. And because this is referring to a method inside of a class, the way it works in JavaScript is we have to say this dot breadth first search, which refers to the class, use the method within this class. And I notice here that we don't need this for the queue because queue is just a parameter. Now, we also want to make sure that we push to the list when we're in here. So just like we did above, we're going to say list dot push the current node dot value. Again, exactly like we've done above here, we want to push the list, the value to the list, because the list is our answer. Now, if I click run here, I'm going to get an error. And this is a bit of a gotcha, a little bit JavaScript specific. And one of the reasons that can get frustrating with JavaScript is that this keyword only works when we're inside of the class, the binary search tree class. Outside of this, remember that we have the tree class that we instantiated. So this is tree.root. And if we run this, we now have our list, this time done recursively. I'll leave this for you to play around with and see which one you like better. But both of these now give us the same results. 9-4, 9-4, 20, 1-6, 15, 170. I'll see you in the next video. Bye-bye.